So we're going to go ahead and pick up where we left off with E. And if you don't recall, we're taking composites of functions. And in this case, we have a numerical input. So this is the process we're going to follow for that. Now, if you recall, I did kind of tantalize you with doing this mentally. So for example, if those of you that want to follow along mentally, I'm going to plug in a 2 in for the function f. So if I plug a 2 in here, 2 plus 2 is 4. And then if I take that 4 and then plug it into the other function, that's 3 times 4 is 12, plus 1 is 13. So E should be 13. Now we can only do that for problems where there is a numerical value, a numerical input to actually place into the function. So we're going to go ahead now and then show you the way to do this algebraically. We begin with putting a 2 into f. So f is x plus 2. We replace that x and make room to input a 2, because that's the input in this case. And then 2 plus 2 results in a 4. Now, this is the value of f of 2. The problem is not asking for just f of 2, it's asking for g of f of 2. So I take this f of 2 value and I plug it into g now. So here's g, and we're going to make some room for the input to go in. The input that's going to go in that spot is going to be what we got from the last problem, f of 2. We do order of operations. 3 times 4 is 12, plus 1 is 13. So we propose that g of f of 2 is equal to 13. Let's kick it back into algebra gear. So here's function f, here's function g, and I want f of g of x. We begin with the outermost function, which is f of x. So I'm going to write that down. And I'm going to prepare a place in this function so that I can put the other function inside of it. In other words, wherever I see an x, I'm going to put parentheses. So what am I going to put inside of f? I'm going to put g. And this is what g of x is. So this is going to go inside of here. Now this is an Algebra 2 class, and Algebra 2 skills are taught, and Algebra 2 skills are expected. Pre-algebra, algebra, and even elementary school skills are expected. So if you're struggling with some of these basic skills, you're going to want to make sure you spend some time on the side reviewing these things. For example, one skill necessary, which I will remind again, is this one right here with x plus 5 to the second power. The power belongs to the entire term or the entire binomial. So a lot of people have been telling me that x plus 5 squared is x squared plus 25. That is not true. That is false. That is fake news. X plus 5 squared means x plus 5 times x plus 5. I write that out twice. And then I distribute. So if I set up my little box here, I get x times x is x squared. And then this is 5x. Don't forget the plus. Have some good habits. You're not bad at math, you just have bad habits. So pick up some good ones. And then 5 times 5, of course, is 25, silly folks, but put a plus in front. That way, when we write this out, right, we get x squared plus 5x plus 5x plus 25. We're not going to do little mistakes. Now, a little mistake that people would do is they would forget that this minus 3 comes along for the ride. Okay, because x plus 5 to the second power means x plus 5 times x plus 5, which means you do all this hokey pokey, which then gives you this expression right here. And now we can go ahead and simplify. So we have a 5x plus a 5x is a 10x. And then 25 minus 3. And so we go ahead and state that f of g of x is equal to x squared plus 10x plus 22. Note that unlike the last problem that we did, there was no numerical input. There was no number in there. So if there is no number, we follow the procedure for doing algebra with x as the input. Here's some comparisons for you. So f of x times g of x. Notice that there's a dot, right? Notice there's a dot right there. So there's an actual dot, meaning multiplication. That's multiplication, okay? Also note how there are two x's. So multiplication was covered in the last lecture videos when we introduced functions to you. So refer to your introduction to functions lecture notes, the back page, to see multiplication in process. For f of g of x, which is what we're discussing now, it's a composite of functions. Notice that there is no dot, right? There is no dot here. And there is only one x. So make sure you can distinguish between those two. So how about the differences between f of g of x and g of f of x? Well, f of g of x means that g of x goes into f of x. Remember turducken. So the order is important here. F of g of x is telling us take g of x, put it inside of f, see what happens. G of f of x, I'm going to ask you to write the words down, but I'm not going to write them for you. I'm going to just say them. G of f of x is asking us to take f of x and to put it into g of x. So they look the same, but the order is not the same. In the first case, g of x goes into f of x. In the second case, f of x goes into g of x. Speaking of turducken, here are three functions, and we're going to go ahead and do a composite. So let's know the order. We have h of x goes inside of g of x, which then all of that goes inside of f of x. So let's prepare each bird. Here is 3 of x. And we're going to go ahead and make some space for us to put in the next one. Well, what's going to go inside of f? G. So let's put g inside of here. But we're not done. We have to make room to plug in h of x inside of g of x. So here's the room that we prepared, and let's go ahead and put h of x in here. So this is the appropriate setup for f of g of h of x. Let's simplify and follow order of operations. So we first distribute this 2 inside of these parentheses. And then we go ahead and distribute this 3 to everybody inside of these parentheses. And we therefore say that f of g of h of x is equal to this. For your summary, explain in words the general process for finding the composite f of g of x of two functions with no number input. And for a bonus summary, try out problem 2 again, but this time I want you to prove that g of f of x equals x squared plus 2.